Well, good morning. This is David Isaac. I'm going to show you a video of the Raspberry Pi, a Linux-based microcomputer, a controller. It's got a little processor in it. So let me see if I can't get the camera set up correctly. And what we're going to do is, you see a lot of wires and all things. The red thing is the Raspberry Pi. It's about a credit card size, a little bit larger because the red enclosure I've got mine in. Computer. And you can do anything you want. It doesn't do anything until you learn about it and tell it what to do. Also, I have right there at the top of the picture, the little star looking thing. That's a servo motor. It's got a motor in it that runs. Then this here, the white part, is a breadboard. And with it, you can plug things in. And then the multicolored wires, black, yellow, red, white, they're jumper wires making connections between the 16-channel servo board from Adafruit back to this main connector, which then connects through this black ribbon cable back to the Raspberry Pi. Here's a little close-up of what that actually looks like. So that black ribbon cable comes off here and plugs in those pins in the middle, and those pins are connected to everything on the side where you can see little letters and numbers and things. It's how you connect back to the processor, the computer processor on the Raspberry Pi. So let's see if we can't get this thing going. Let me get the camera set up. This will take just a moment. Let's see. A little bit better lighting. Okay, we'll see if that works out. So, got this hooked up with a serial cable. This right here, you can't see it, but the other end of it hooks up to my laptop so I can connect to the Raspberry Pi. I'll show you that in just a minute. Get logged into the computer here. Good. So then, here's the power running off of here for the Raspberry Pi. It's 5 volts. It plugs in right in here. Oh, I see I have a ground wire loose off of the servo motor. So let's see what happens when I plug in the Raspberry Pi. This is what's called a command shell. It's Linux operating system. Right now, I've shut down the Raspberry Pi because I have the power cable out. We'll see what happens. Give me a moment and I'll show you what happens when I plug in the power. It'll load up Linux. And there it goes. Boom. So Linux is open source. It's been around for years. It's an operating system. This one's specifically made for small processors. Raspberry Pi, $35 for that. Maybe it hasn't got a lot of power, but it can do a lot of things. So it's loading up, as opposed to Apple, iOS, or Windows. Those are closed. You can't do anything with them. Here, I can do anything I want. And if I log in as a super user, which I'm not going to do right away, I can go in and destroy things. But you be careful, you learn, you find out what's going on. And as a super user, you can go in and change things, unlike Windows or Apple iOS, because you're unable to go in there. They don't allow you to change anything. And that's the beauty of the Raspberry Pi and its Linux operating system. It's a distribution called Raspbian, and I'm using one from Adafruit. It's been modified, called Occidentalis. which is actually, let's see, the species name of the Raspberry Pi, of raspberry, the actual plant. So anyway, that means people, Adafruit through Occidentalis, Linux, Raspbian, they've been able to go in and make their own operating systems using the base code of Linux. So that means I can go in and do things too. So we'll see what we can do here. So I'm going to log in, Raspberry login. You can see there at the bottom. Hope it's in focus. Put in my password, hook it up to the internet, do all sorts of things. So we're going to run a little motor here. Oh, didn't log in right. Computers are nice because they're very specific. There's no opinions on them. Good, I'm logged in. So it says Pi at Raspberry Pi, colon, little tilde symbol, and a $sign. That means I'm ready to go. So let me do some changes here, and I'll put you back to watching what's going on. Okay. So I've got power hooked up. Next thing I'm going to do is this motor, even though I have 5 volts available, actually on this connector, but right there on that pin, the second pin down, here at the top, second one, it says 5V. So actually I can get 5 volts off of the Raspberry Pi, because that's what I'm putting into it. But the servo motor, you know, it actually takes a little bit more current, and there's a clocking thing, a timing thing, where if I ran it off the Raspberry Pi, it's 5 volts power coming in into the servo motor. This is where the motor's hooked up. It'd be jittery and it'd be unpredictable. So to get a predictable power supply, I've got an adapter here that gives me 5 volts. So it's independent. And as you can see, it's running into this terminal block, positive and negative. And then I'm running power off into here. In fact, I kind of notice I've got a ground wire. So if you notice, a lot of times you see 3 wires coming in and off things. That's because, oh, there. With any circuit, you need a positive and a negative, voltage in, then a ground for it to run to. And in this case, same thing. The black wire is ground. It's running to ground, while the red wire is the voltage coming in. And then secondly, the yellow wire there is actually the signal that drives everything. So I want to make sure everything's on. So I can hook up servo motors and other pulse width modulation devices to the other 15 of these pin sets. And this little processor will drive it. Okay, but let's go ahead and see if we can get something moving here. So what I'm doing now is changing to some directories. It'll take just a moment. For instance, really nice. This information's from Adafruit. They put it together. It shows you just all how to do it, to put everything together. Here's specifically what I'm going to do. This little device with all the pins on them is the Adafruit 16-channel servo driver. Works with the Raspberry Pi. You can see it down here in the lower right-hand corner. Here's a servo, and here's a Raspberry Pi with a clear case, servo, and the 16-channel servo driver. So it just makes things a lot easier with this, because it does some things that make it so I don't have to do them, like coding and things. These are a PDF file. Gives me nice guide contents. Gives me an overview, what we're talking about. PWN, Pulse Width Modulation. It's how all motors are driven. Okay, tells me what I need. So we've got all those items. See, the 16-channel 12-bit servo driver, a PI cobbler, which is actually this right here, the white breadboard, the servo motor, power adapter to get my 5 volts into it, and then a 5-volt power supply. And that tells you all how to get it done. But what I'm going to drop into real quick, fairly quick, is I'm going to get to where I need the piece of code that's in Linux in the Occidentalis. So I'm going to copy that, Control-C, boy, one of the best things Bill Gates ever invented, and I'm going to come back to the Raspberry Pi. It's hard to see, but it's in blue there. That's where I want to get. It's called adafruit-raspberry-pi-python.code. In other words, Adafruit built some code. Some smarter people than me know how to program. Put it in there. So I'm going to Control-paste, actually right-click here in Linux, and I'm going to change the directory to there. There it is. Hit Enter. Now I'm in it. Then I want to go a little bit deeper with Adafruit Pulse Width Modulation servo driver. It's another piece of code inside this directory, kind of like a drawer in a file cabinet, just where everything's kept so it's all organized. And the computer, both you yourself, the programmer, and yes, you'd be a programmer doing this, and the computer knows where they're at. So now I'm going to right click, change directory to there, and there it is. Now in Linux, I can do an ls for list what's in that directory, that Adafruit _pwn _servo _driver. And this is the one I want to do, is right here, I believe. So we're going to come in here. Here's all things you got to configure and set up right, so I didn't want to bore you with that, but it's pretty interesting. And here's what I want to run. This sudo python example py. Sudo means super user do. It gives it, since this is my Raspberry Pi, I have permissions to become a super user, to go in deeper into the computer and do things that a normal user wouldn't. So in other words, if you don't have super user permissions, you can't destroy anything. But I'm not trying to destroy anything, hopefully. I'm just trying to run things. I'm going to be using a programming language called Python, really easy to use. Children are often taught it as an introduction to programming. And so I'm going to super user, tell the computer use Python to run this servo _example.py. The py tells the Raspberry Pi that it's a Python file, .py, like doc for a Word file. Okay, so I'm going to copy that. And I'm not sure if I got everything hooked up, but let's just give it a try and see if we get anything. Oh, we did. So in running that, if you can see, some different parameters are being placed in there. The pulse width modulation, the frequency, and it's running that continuous servo. So just to summarize real quick, I have power coming in for the servo, power coming in also for the Raspberry Pi. The Raspberry Pi is being connected through this ribbon cable into this cobbler. It's actually a T cobbler. It's in the shape of a T with these wires coming off. These 3 wires are just going back to my laptop so I can interact with my Raspberry Pi sitting here with a big keyboard, big screen. Uses a program called Putty, P-U-T-T-Y. It's just a serial interface. Okay. The rest of these wires, the black ones are ground. There happens to be a wire coming off here. That's connected to a pin. It's hard to see because it's dark. A ground pin on the Raspberry Pi. So I'm making use of the ground there and creating this strip here. All in the blue, the outer strip, all is grounds. So when I connect this to strip to ground along here, this length, then all these are grounds. And I make a jumper from here to make a ground on the other side. And then these black wires are all grounds, in this case, to the servo, Adafruit 16-channel servo module. And then running power off, signals from the Raspberry Pi. And so this can tell this through here for that to do that. So Once you got that running around, you can do all sorts of things. You can make it stop, go back and forth, rotate 90 degrees, go back, hook it up to a photocell, or hook it up to the internet very easily to your local longitude and latitude, so it knows every day when sunrise is. So you can program it and say, now 30 minutes after sunrise, no matter how sunrise changes the time throughout the year, make the servo motor rotate for 15 revolutions, connected to a wire that opens up the door to let the chickens out so they can go feed themselves, so you don't have to walk outside. Many examples. Home security systems, garage door openers, everything uses these mini controllers nowadays. You see them everywhere. So anyway, that's just an example of what happens today. We'll see what else we can do. This is part 1.